Hi everyone, welcome to my channel STB Academy. Today we are going to discuss about physics, grade 10, Cbse, light reflection and refraction. In Cbse we have 4 chapters. Those are light reflection and refraction, human and colorful world, electricity, and magnetic effects of electric current. Now in this video we will come purely discuss about light chapter, that is light reflection. Light travels in a straight line in homogeneous medium. So what is homogeneous medium? In a medium, all the particles exhibit same nature. That is called homogeneous medium. And coming to the reflection of light, so children, dear learners, you can observe here. In the left side, I given notes. In the right side, so I will be explaining. In left side, all the diagrams and the content will be there available. You can note down. In right side, my explanation will be there for the content. So you can check it once. Here, if you take reflection of light, reflection of light. So what is the reflection of light? So then you take the plane mirror. I am considering the plane mirror. So when you consider the incident ray, so here the yellow part you can observe. In the yellow part, incident ray, that is called incident ray. I am considering this. If you take this reflected light ray, reflector light ray, the line which is perpendicular to the plane surface, that is a dotted line we are drawing. So the angle between incident ray and normal line, this is the incident ray and normal line, then that is called angle of incidence. Angle between reflected ray and normal line, that is called angle of reflection. The deviator line, the line which is deviating from the surface, so that is called deviator line. So the angle between reflected and deviator line, that is known as angle of deviation. So as you can see here, incident ray, reflected ray, the line which is perpendicular plane surface, that is normal line. The line is deviating from the surface, that is a deviator line. The angle between incident ray and normal line, angle of incidence. Angle between reflected and normal line, that is called reflection angle. So the angle between deviated line and the reflected light, that is called deviated angle. As you can see here, the same the content will be there for writing notes. You can note down all the points. The property of light coming back into the same medium from the boundary separating two media, that is the definition. As I said, light is incidenting on the surface, then reflected back. This entire phenomena is known as reflection of light. So you can see here, AO is the incident ray, this AO incident ray, OB is the reflected ray, and angle of incident, angle of reflection, and deviation angle and glancing angle. It's very important. The angle between incident ray and plane surface. The angle between, as you can see here, you can observe here, the angle between incident ray and plane surface, that is called glancing angle of incident, denoted with the alpha I. Glancing angle of incidence, that is the reason alpha I. Normally alpha you can take, let's say glancing angle. Then loss of reflection. There are two laws of reflection, very important, especially in the exam. Sometimes they will ask questions related to this concept. So as you know, incident ray, reflected ray, and normal line. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line, angle of reflection. The first point is angle of incident always equal to angle of reflection. Second one is, so angle of incidence. What is the angle of incidence? Angle of incidence always equal to angle of reflection for any surface. For any surface, so this two angle of incident is equal to angle of reflection. And incident ray, that is nothing but incident ray, reflected ray, and normal line. Incident ray, this is a normal line. You can consider this is incident ray and reflected ray and normal line. Incident ray, reflected ray, and normal line. So lies on the same plane, So this notes you can note down. Angle of incident is equal to angle of reflection, that is nothing but symbol, and the incident ray, normal, reflected ray, all lie in the same plane. So this is a diagram you can see, observe. So next, types of reflection. So what are the types of reflection? There are two types of reflections are there. One is regular reflection. Another one is irregular reflection. Irregular reflection. So what is a regular reflection and irregular reflection? First one is regular reflection. If you take this as plane surface, that is nothing but smooth surface. So the parallel beam of light incident on the surface, the parallel beam of light incident on the surface, then the reflected beam must be parallel to each other, must be parallel to each other. So if the incident, whatever the light beam is incident, if the parallel beam of light incident on the surface, then the reflected beam also parallel. Then this type of reflection is called regular reflection. As you can see, if the parallel beam of light incident on the surface, the reflected beam also parallel. This type of reflection is called regular reflection. As you see, smooth surface, incident beam, parallel beam, reflected beam also parallel to each other. Then plane mirror and coating surface. Then you can see the regular reflection. What is irregular reflection? So you can take the rough surface. This is a rough surface. I'm taking the rough surface. So parallel beam of light incident on the surface. Then the reflected beam is does not parallel to each other. The reflected beam is does not parallel to each other. It will go in different directions. So rough surface. You can observe here. This is a rough surface. So parallel beam of light incident on the surface. Reflected beam is not parallel to each other. So definition: if the parallel beam of light incident on the rough surface, the reflected beam is not parallel, then this type of reflection is called irregular reflection. So very important quotation. So in the exam there are this question will come. So in the exam, so very important statement. That is nothing but, so laws of reflection are valid for all surfaces, either smooth surface, rough surface, curved surface, any surface you take. Laws of reflection are valid for all surface. Suppose you take the plane mirror. I'm considering the plane mirror. So this is a plane mirror I'm taking. When the light is incidenting on the surface, then reflected back, normal line. So angle of incident, that is nothing but angle I, angle R, and this always, as you discussed in the previous class, so previous video, previous topic. So here you can see angle of incident always equal to angle of reflection. Incident ray, normal and reflected ray lies on the same plane. So you can take that is a smooth surface. Coming to rough surface also you take. So incident ray, reflected beam, reflected light and normal line. Angle of incident always equal to angle of reflection. So the same. And coming to the curved surface, you take the curved surface also. So incident light ray, reflected light ray. Then so if you take this normal line, then angle of incident is equal to angle of reflection. So they are like that you can consider. So all these surfaces, so the laws of reflection are valid. So very important point. Then coming to the object. So what is object? So object I will explain here. Then you can go for the statement, definition, everything. So I am taking, so plane mirror I am taking. So this plane mirror. So principal axis I am taking. So this is the object. So point object I am taking. This is a point object. So light rays will be incidenting. So then it will be reflected back. So you can take this reflected back. Then you can take like this also. Then you can take like this also. Okay. So like that we can consider. And then it will be reflected back like this also. You can take this normal line. Then it will be taking. So then it will be considered normal line. You can consider. Then light is reflected back into the same medium as like a reflection phenomena. Then you see this is the incident ray. So in this diagram, so this is incident ray and this one also incident ray. When the so this incident ray are incidenting on the surface, then it will be reflected back. So here you can see the point of the definition. Coming to the definition, the point of intersection of incident rays. Here what are the incident rays? 1, 2. So these are the incident rays. Where these incident rays are coming from this point. So the point of intersection of incident rays is called as object, or anything which gives us light rays is called object. Anything which gives to us light rays is called object. So from this point only light rays are coming. So this is giving light to us. So this point is called object. Coming to the image. So what is image? So image also we can see here. I'm taking the plane mirror like this. So principal axis, that is my normal line. So when light rays are coming from infinity, so light rays are coming from infinity, suppose I'm taking like this, and so object I'm considering here. So object also I'm considering here. Then light rays, you can take this light ray, this light ray. After reflection, those light rays are meeting at one point. So one point you can consider. So maybe the reflection takes place, then it will be considered like this. So you can take the reverse of that one. So you can take, so light rays are coming from infinity, like some object. Then after that, so the light rays are meeting at one point. Meeting at one point you can consider. One point you can consider. Okay. So that also we can take. And one more example also I'll give, just 1 minute. So instead of that, you can take one mirror. So this one mirror I'm considering. So light rays are coming from one point. So I'm taking like this. This also mirror, it's in the form of curved mirror. So we can discuss in the further class. So light rays are coming from infinity. After reflection, those light rays are meeting at one point. So you can see the definition image. The point of intersection of reflected rays is called as image. So these are the incident rays. After reflection, those are meeting at one point. Those are meeting at one point. So our image is an optical appearance produced when light rays coming from an object or reflected from the mirror. So means these light rays are coming from infinity. After reflection, those light rays are meeting at one point. So that is called image. Then coming to the types of images. So types of images. So there are two types of images are there. One is real image, another one is virtual image. So real image and virtual image will discuss. So as I said, so we can observe here real image and virtual image. Real image means you take the mirror, same previous mirror. So you can take when light rays are coming from infinity. After reflection, those light rays are meeting at one point. So this this intersecting point, this will be considered as intersecting point. Okay, so here you can see the definition. Image which can be obtained on screen is called real image, or if the reflector rays intersect, the point of intersection is called as real image. So these are the reflector light rays. Those reflector light rays are meeting at one point. So that is called real image. And coming to the virtual image you see, I'm taking virtual image. So mirror, one more mirror also we can take, that is in curved shape. So like this also we can take. So previous one mirror is concave mirror. So this one is the convex mirror I'm considering, convex. So when light rays are considering, light rays are coming from infinity. So these are the light rays are coming from infinity like this. After reflection, those light rays are diverging, means moving away from the principal axis. Then you extended this light rays, those are meeting at one point. Those are meeting at one point. So which one we are extending? We are extending the reflector light rays. These are the reflector light rays. So these reflector light rays are we are extending. So those light rays are meeting at one point. So this is our incident ray, this is incident ray. So this one is reflected, this one is reflected. You are extending this reflector light ray. Those are meeting at one point. So you can see the virtual image definition. Image which cannot be obtained on a screen is called virtual image. Or if the rays diverge after reflection, rays so diverge. So these are the divergent light rays. Diverge after reflection, then the point of intersection of extended reflected rays. So what is the point? The point of intersection of extended reflected rays. So these are the reflected light rays, these are the reflected light rays, those are meeting at one point. So the point of intersection of reflected rays is called virtual image. Then we'll go for the characteristics of the image formed by the plane mirror. So you take the plane mirror, I'm considering like this, the plane mirror. So object I am taking. So here is object. So this object I am considering. So light rays are coming from object. One light I am taking. So this is a reflector light ray, and one more light also I am taking light. So this will be reflected back. So then you can extend it, this one extended, and this one also extended. You can take one more light ray. This is one more light ray you can take, that will be reflected back. Then along this one also you can take and reflected back. If you extended this light rays, the image will be forming here. Image will be forming here. So their image will be forming. This is called virtual image. This is called virtual image. As you see this line you can take. So then dotted lines, if you draw this also, that also image will be forming. So this is called virtual image. So if the object is real, image is virtual. Object is real, image is virtual. So this is the main diagram. Students, you can draw the main diagram. This is a rough diagram for our understanding, for explanation I am drawing. So you can draw this main diagram. If the object is real, image is virtual. So vice versa means if the object is virtual, image is real. So like that we can take. And here what are the, this is a real object and virtual image. And if it is take one more, virtual object you take, real image will form. Okay. So here object is real, the image formed in the plane mirror is virtual. So here what type of image is forming? Virtual erect. Virtual erect. Virtual erect, what is that? So if object you take like this, object you take the like this, image also will be the same. Image also will be the same type. If you bottle you take, this is a bottle, water bottle. You can take the water bottle like this. So water bottle also placed, image also will be formed like this. So whereas inverted image means if you water bottle you take like this. So and you may, in the inverted image form it will be inverted like this. So downward, upright. So whereas in the virtual image, so however the object is there, so image also will be formed like that only. So same like that. So that is virtual image. So here is virtual image. So in the plane mirror, what type of image is forming? Virtual, erect and same size. Same size. Same size means same height and same distance too. What is the distance? So the distance between object to mirror is equal to the distance between image to mirror. So equal distance. So what, how much of the distance between object to image? So that is equal to object distance between mirror to image. So like that, same distance. Then lateral inversion is this concept is very important. So in the board exam also it will come. So consider student, consider learners. So then you can take, I am taking the plane mirror like this. So if you consider the B letter, alphabet B letter. So in the mirror it will appears like this. The mirror it will appears like this. Suppose I am taking this is the left, this is the right, and here you can see this is the left and this is the right. So order you have to follow. Order is LR. So here also LR. But you can see here in the case of no, that L you can see here, order you followed, but here you can observe the main point is, so whatever the left, so order, so you can see here, whatever the order you followed, here it is left, right, left is this side, but here it become, what it became, so here it is, this is the left, this is the right, okay na? So because whatever the sides you have to take. So here it is left. What is left? So this side is this the line. This side is left and this side is right. So here you can see our left became right. So it's like whatever the order. So actually this, if you take this order, so this also LR, right? So the same order. But here in this image you see this left became right side. So this right side became left side. This right side became left side. So that is the definition of the image. So here you can observe. So even if you stand in front of the mirror, then our right side appears to be left side and left side appears to be right side. Here you see, when an object is placed in front of the mirror, then the right side of the object appears to be left side of the image. Right side of the object appears to be left side of the image. Left side of the image. And the left side of the object appears to be right side of the image. Left side of the object appears to be right side of the image. So this changes of the side of an object in its mirror image is called lateral inversion. So what I am trying to explain is, so whatever the object you place in front of the mirror, so it left it appears to be right, right appears to be left side of the image. So that is the mirror image. Right side appears to be left side appears to be right side. So that is about the lateral inversion. So coming to the spherical mirror, so you can see the spherical mirror. So the mirror which is in the form of curved shape, that is called spherical mirror. So you can take a spherical mirror here, you can observe. So when you are considering curved surface, so we are taking the up. So if you take the curved surface, so like this, so we are considering the half of it, half of the mirror, then that is nothing but curved mirror. So that is also called spherical mirror. When you are cutting half of that one, that is curvature. So here you can observe like this. So one side is reflecting surface, another side will be coated. So one more definition also, the reflecting surface will be inward, then coating will be outward, then that mirror is called concave mirror. And convex mirror you can consider, so reflecting surface will be outward, so curved reflecting surface will be outward, curved inward, then it is called convex mirror. So as you can see the diagram, you can see this is concave mirror and convex mirror. Then in spherical mirrors, there are terms in spherical mirrors are there. What are the points we can see? So in the left side you can observe pole, center curvature, radius of curvature, principal axis, aperture, normal, principal of focus and focal length. So we will be discussing one by one. So now you can observe. So what are the terms related to spherical mirror? So I'm considering the diagram, rough diagram I will draw. So this is a rough diagram. You can see if you take the concave mirror, I am taking the concave mirror, consider like this. So the middle, the point on the mirror at the middle point. So here exactly, so you can take, so this point is nothing but, so that is here, this point is called pole. So you can see the definition also. The point on the mirror at the middle of the surface is called pole. This is the pole. And center of curvature. So what is the center of curvature? You can take this sphere. This sphere you can take sphere. For this sphere, normally you take the circle. For center will be there. Center will be there. But we took curvature. No? So we took curvature here. This is a curvature. So here it is point will be there. So this point will be considered as a center of curvature. This point will be considered as a center of curvature because the curvature. So the definition is the center of the sphere. This entirety is sphere. The center of the sphere of which the mirror is a part is called center of the curvature. So what mirror we took? Curvature. So curved shape mirror we took. So that is the reason the center of the sphere of which of which the mirror is a part is called center of curvature. Coming to the radius of curvature, as I already discussed, if you take the sphere from center to one point on the sphere, then that is called radius. So here also the same, from center of curvature to pole, that is called radius of curvature. Radius of curvature denoted with the capital letter R. So radius of curvature. So the radius of sphere of which the mirror is a part is called radius of curvature. Coming to the principal axis. What is the principal axis? So that the line joining of the pole and the center of curvature is called principal axis. The line joining of the pole and the center of curvature is called principal axis. So what is the pole? This is the pole. Here it is pole. So where is the center of curvature? It is center of curvature. The line joining. What is the line joining? This is the line joining. The line joining, that is called principal axis. Principal axis. Principal axis. So then aperture. So what is aperture? The diameter of the enclosed curved portion. The diameter of the enclosed curved portion of the curved mirror is called aperture of the mirror. So the diameter of the enclosed circular portion of the curved mirror is called aperture of the mirror. So the width of the mirror, simply this is the width of the mirror. So this distance is called aperture. So here from here to here, this portion is called aperture. So this distance is nothing but aperture. Aperture we are discussing. Then next normal. So normal is nothing but, so the line joining of the point of incidence and the center of curvature is known as normal to the point of incidence. Normal to the point of incidence. Suppose, so this is center of curvature, we already know. So if you take from here to here, then it is normal. From here to here, that is normal. You can take any point. You can take any point. Like normally you take the circle, so you can consider here this is a circle. So from point to any line, so this will act as a normal to the point of instance. So that is the reason that is called normal. Next one, principal focus. So what is the principal focus? So you can see here, and in this diagram, so light rays are coming from infinity. So these are the light rays coming from infinity. After reflection, those light rays are meeting at one point. After reflection, those light rays are meeting at one point. So those light rays are called. So this is one light ray, this one light ray, these two light rays are coming from infinity. After reflection, light rays are meeting at one point. So that point is called principal focus. Thus point is nothing but principal focus, denoted with the letter capital F. Capital F. So now you can see focal length. So focal length, I will draw one more diagram, because same diagram only I will draw, because everything mixed, no. So that's the reason you can take here. So as I said, the light rays are coming from infinity. After reflection, those light rays are meeting at one point, that is called focus. So this already said, this is a pole. So the distance between focus to pole, that is nothing but focal length. So here you can see these light rays are coming from infinity. After reflection, light rays are meeting at one point. So that point is called a principal focus. This is the pole. The distance between focus to pole, this is called principal. Sorry, that is called focal length. So here you can see the definition. So you can observe the definition also. You can see there. When the parallel beam of light is incident on the reflecting surface, then the point of from which the reflector rays appears to be convergent or divergent is called principal focus. Convergent or divergent is nothing but, then normally you take so convex mirror. So you can observe here, convex mirror I am taking. If you take the convex mirror, light rays are coming from infinity. After reflection, those light rays are reflecting like this, diverging. So here it is pole and focus and center of curvature. So the divergent light rays, if you extended, those light rays are meeting at one point. So that is focus. So here also, this also focus, this also focus. So we can consider this for concave mirror, this for convex mirror. So that is about the focal length. So here you can see the focal length is equal to radius of curvature by 2. So that is nothing but r equal to 2f. So f equal to r by 2. Then you can see here, next one, we can determine the focal length of the concave mirror. So we can determine the focal length of the concave mirror. So in two methods we can discuss. This is a concave mirror I am considering. So one is you place the distance object. So if you take the distance object, then light rays are coming from distance object. After reflection, light rays are meeting at one point. Then those you can take from here also, light rays. Suppose so object is somewhere else. So from there light rays are coming from. Then after reflection, light rays are meeting at one point, that is called focus. So the distance between so principal focus to pole, that is called focal length. So this is called focal length. By this also we can find out the focal length of the concave mirror, or you can take the sun rays. So you can take the you place in front of the sun, then light rays are coming. After reflection, those light rays are meeting, then from so focus, principal focus to pole, that is called focal length. So by these two methods, we can identify focal length of the concave mirror. So here it is concave mirror, it shows the converging nature. Convex mirror, it shows the diverging nature. So here you see forming the image of the distance object. Distance between pole to image form called focal length, and focusing sunlight. Distance between pole to point of convergence sunlight is called focal length. So as I discussed, so those are the 2 points. So here you can see the concave mirror. So why concave mirror is called converging mirror? Because when the light rays are falling on it, if you consider light rays are incidenting on it, then after reflection light rays will be converged, or make the light rays will meet at one point on the principal axis. So these light rays are coming from infinity. After reflection light rays are meeting at one point on the principal axis. So that is the reason it is called converging mirror. Then why it is considered as a convex mirror as a diverging mirror? Why means, so when light rays are falling on the convex mirror, so you can observe here convex mirror. So after reflection, those will be so moving away from it. So moving away from it, then moving away from principal axis, moving away from the principal axis. So those are light rays will be diverging from the principal axis, away, moving away from the principal axis. So that is the reason. So this mirror is called diverging mirror. Then apart countless rays. So next one is image ray rules. Then image formation we will discuss. You take so if you want to form the image of the object, so minimum 2 light rays are required to form the image of the object. So there are so many light rays are coming from infinity. There are so many light rays are coming from infinity. Apart countless rays, so we need only 2 rays to form the image of the object. So you can see here, although countless rays starts from a given point of an illuminated object. Object means the light object, the object which is giving the light. So there is an illuminated object. Yet it is possible to locate the position of an image formed in a spherical mirror by taking any of 2 light rays. Any of 2 light rays. So here you can see. So if you want to form the image of the object, we don't. So we, from starting onwards, you can observe the diagram, same diagram I'm drawing. So that is only 2 light rays I'm taking. So I'm not taking many light rays, only 2 light rays I'm taking. So the minimum light rays required to form the image of the object is 2. Minimum is 2 light rays. So consider object placed in front of the curved surface. As you know, so now we are going for learning the ray rules of the concave mirror, like for drawing the image formations we need 2 light rays are required. So I already said. So how many light rays are required to form the image? Minimum 2. So we need to learn the ray rules. What are the ray rules are there? So now we will learn. So ray passing through the center of curvature retraces the same path after reflection. So we are talking about ray rules. So mirror you are taking, say, 2 mirrors. One is concave mirror. So this is a concave mirror. Reflection takes place inward. Another one is a convex mirror. Reflection takes place outward. So what is the definition? So ray passing through the center of curvature retraces same path after reflection. So suppose you already so pole, focus and center of curvature. Center of curvature. So as you know, when the light is passing through the center of curvature, after incidenting it will reflect back into the same medium. As you take the circle, on the line you take, that is it will act as a normal. So as I said, so from the center to point of incident it will act as a normal line, then it retakes its same path. So for the convex mirror also the same. Pole I am taking, focus and center curvature I am taking. So when the light is incidenting along the center curvature, so if you take like this, passes the center curvature, it takes its original path. So here you can see this original content, you can take a notes. So ray 2, what is a ray 2? So here you can take, so ray passing parallel to the principal axis reflected back or appear to be reflected through the focus. Here you see incidenting, it will be reflected back. So I will draw the diagram, then you can understand clearly. So I am considering here, so concave mirror I am taking. So pole, everything you have to take, pole, focus and center curvature. When the light is incidenting on it, then it will be reflected back. so passes through the focus. Where you take the convex mirror, so when the light is inciding on it, it will be reflected back. So you can take the pole, focus and center curvature. Then if you extended this, it will passes through the focus. So you can observe here, it will passes through the focus. Next one, ray passing through the principal axis. Ray passing through the principal axis. Ray passing through the principal axis. Next, coming to the third rule, that is nothing but ray passing through the principal focus appear to passes through the focus after the reflection of the, okay. So third rule you can see, if you are taking this one concave mirror, when the light ray is, so I am considering the pole, focus and center of curvature, the light ray is coming parallel to the principal axis, after that passes through the focus. Then you can consider, so if the same convex mirror, if the light is passing through that one, after that diverge and passes through the, so pole, this center curvature, extend passes through the focus. So reverse of it is third ray rule. So you can take the, this is the second ray rule. Coming to this second ray rule. So similar to the opposite of the second rule is third ray rule. So I am taking the pole, focus and center of curvature. If the light ray is passing through the focus, so this is a convex mirror, right? If taking like this, then after that it will passes towards parallel to the principal axis. Then the concave mirror you take, so when the light is passing through the focus, so pole, if it is passing through the focus after reflection, parallel to the principal axis and passes to the infinity. Then you can see here ray 4 you consider here. Then if it is incidenting obliquely at the pole, so pole, focus and center curvature, then light is incidenting at the pole, it will be reflected back to the same media. Even if the convex mirror also the same, pole, focus and center curvature, if it is incidenting at the pole, it will be reflected back. So that is about the ray rules. And coming to the formation of the images by concave mirror, so here you can observe, everyone, here you can observe when the object is at infinity. So when the object is at infinity, now image formation by concave mirror. So I am taking the concave mirror like this. So if the light is, if object is at infinity, so light rays coming from infinity, so focus and center of curvature I am taking. The light rays are passing from coming from infinity, after reflection meet at focus, where image is forming at focus. So what is the nature of the image? Real, inverted is nothing but so up and right, and real, inverted and highly diminished image is forming at focus, image is for focus. So that's about the first case. And coming to the second case, so second case you see, when the object is placed beyond center curvature, I'm taking. So if I'm considering object is placed, so pole and focus and center curvature, if I place the object beyond center curvature, one light I am taking here, it passes through the focus, another light it passes through the center curvature, then it will be meeting, image will be forming between center curvature, object beyond center curvature, image is forming between center curvature and focus. What is the nature of the image? Real, inverted and diminished image is formed. Compared to the object, image size is reduced, so decreased. That is about the second ray rule. Coming to the third ray rule, so if you are taking the third ray rule, so same we are taking, so pole, focus and center curvature, If I place the object at center curvature, so image also will be forming at center curvature only. One light I am taking, so it passes through the focus, another light ray, it will be meeting, then image will be forming exactly at center curvature. So object at center curvature, image also at center curvature. What is the nature of the image? Real, inverted, and same size image will be forming at center curvature. And coming to the fourth case, when the object is placed between center curvature and focus. So I'm taking the object is placed, so pole, focus and center curvature. If the object is placed between center curvature and focus, image is forming beyond center curvature, so image is forming here. So you can see the original diagram besides of that. So you can observe here, is this the original diagram, then it's a rough purpose. So just for explanation I am drawing. So here object is between center curvature and focus, where image is forming beyond center curvature. What is the nature of the image? Inverted and enlarged image. Why it is enlarged compared to the object? So here it is object, compared to the object image size is increased. So compared to the object image size increased, that is the reason it is enlarged. And coming to the next position is, so when you place the object at center curvature, focus, so pole, focus and center curvature, if you place the object at focus, so image will be forming. One light I am taking, it passes through the focus, another light I am taking, it passes towards reflected pole and passes towards infinity. So parallel lines never meet, it will form it. So where image is formed at infinity. So object at F, image is forming at infinity. Object means at focus, image is forming at infinity. What is the nature of the image? Real, inverted. This is the nature of the image. So size is highly enlarged, highly enlarged, highly enlarged, highly enlarged. Image is forming at infinity. And the last sixth case is very important. This is the sixth case. So many times in the board exam they ask this question. Very important. Very start. Okay, you have to put star marks. So 5 stars also you can keep. 3 marks question they will be asking this question. Then if you are taking a pole, focus and center curvature, if I place the object between focus and pole, one light I am taking like this, another light I am taking. So if you extended this light rays, those will be meeting at one point behind the mirror. One point, actually this is the dotted lines. So you can see here in main diagram you can observe. So image is we drawn image with the dotted lines because that's a virtual image. So you can observe here, this is a virtual image, that is the reason we are drawing with the dotted lines. So here also you can see, so if you place the object between focus and pole, image will be forming behind the mirror. What is the nature of the image? In this case only this case only will get a virtual and erect, and third point is enlarged image. Enlarged image is forming, virtual erect and enlarged image is forming behind the mirror, behind the mirror. So that is our sixth case. Coming to the convex mirror. In convex mirror only two cases are there. So only two cases. One when the object is placed at infinity. So you are taking convex mirror, pole, focus and center curvature because the sphere is this side. That is the reason we placed. So if you are taking object at infinity, one light I am taking, another light I am taking. After a reflection, those light rays will diverge. Then you extended this light rays, reflected light rays will be meeting at focus. So object at infinity, image is forming at focus. What is the nature of the image? Virtual, erect and highly diminished. Virtual, erect and highly diminished. Highly diminished image is formed. So formed at focus. So that is of the first case. Coming to the second case. So when you place the object, so I am taking the convex mirror. So pole and focus, center curvature. If I place the object anywhere between infinity and pole, So one light ray I am taking, another light ray, it will be incidenting at the pole, then it will be reflected back. Then you extended this light rays, those will be passing. Those will be meeting in front of the, so means between pole and focus. So object between infinity and pole. So image is forming between pole and focus. What is the nature of the image? Virtual, erect, and diminished image. Compared to the object, image size is decreased. Diminished image is formed. So that is about the nature of the convex mirror. Next one, coming to the field U. So what is field U? So if you are taking extreme reflector light rays, so field U I will explain. If I am considering the, so plane mirror like this, so one side is coated, another side is the reflecting surface. When the light is incidenting, it will be reflected back like this. Okay, so the region between extreme reflector light rays, so this one is a reflector light ray, this one is a reflector light ray. The region between extreme reflector light rays, that is known as field U. So here you can observe, if the object is placed in front of the any mirror, then the region between the reflected rays from the edges of the mirror is called field U. So edges of the mirror or extreme reflector light rays also we can say that is field U. So field U is more for convex mirror. So this is a convex mirror, field U is more. So you take the plane mirror and concave mirror, compared to these two, convex mirror field U is more. Then we'll go for sign conventions. Sign conventions are very important. Even in the problem also we'll be asking about these sign conventions. So make sure that you're learning these sign conventions. So what are the sign conventions? So you take the concave mirror, so pole, focus and center of curvature. So all the measurements will be considered from the pole. All the measurements, so first point, all the measurements will be considered from the pole. So in the direction of incident rays, because these are the incident rays coming from the object. So anyway, object placed in front of mirror only. So all the measurements will be considered in the direction of incident rays positive. What are those? So radius of curvature, focal length, and object distance and image distance. All are positive. All are positive. Object distance and image distance all are positive. In the direction of opposite incident rays, so radius of curvature negative, focal length negative, object distance negative, image distance negative, all are negative. So if you're considering above the principal axis, height of the image and height of the object both are positive. Below the principal axis, height of the image and height of the object both are negative. So this about new Cartesian sign conventions are sign conventions. Simply sign conventions we can take. So convex mirror has larger field U, then concave mirror has this already you know, new Cartesian sign convention. So here you can see concave mirror. So here you can observe all the points. If the pole of the mirror taken as the origin, principal axis of the mirror is known as x-axis. So this is the principal axis known as x-axis. All the distance parallel to the principal axis are measured from the pole of the mirror. As I said, all the measurement will be considered from the pole only. Then the distance measured perpendicular to the above the principal axis taken as positive means above the principal axis taken as positive and below the principal axis taken as negative. Then all the distances in the direction of incident is positive, in the direction of incident is positive, in the direction opposite incident is negative. So those are sign conventions. And next we are going for the